When we're at this blockchain node side, a consensus request is received. Then we want to do resolve conflict. From now, let's create this blockchain node side's API. Let's go to projects, then blockchain server, then blockchain server.go. We're going to create a new API called consensus. I'm going to create some space here, and we'll start writing with func bcs blockchain server followed by consensus. And this is a repeat of what we've done before. We have HTTP response writer rec HTTP request, followed by switch rec method, then case HTTP method put this time. We want to resolve conflict and update our blockchain, so that's why it's put. Then bcs get blockchain. When we get blockchain, we'll do bc resolve conflicts here. Then we'll return a bool as to whether this has been replaced or not. Next, we want to return this information, so w header add content type application JSON. If this has been replaced, then io write string w string utils JSON status success. If it hasn't been replaced, then we'll change this success to fail. Then what's left as default. This will be w write header HTTP status bad request. If we want to write a log for this, we'll write the line for this here like so. Invalid HTTP method. Now all we need to do is register the API for a consensus down below. We'll copy this and rewrite this to consensus. This is how we register the API for the consensus that we just created. And by doing this, then when our consensus API is called on, then this 5001 will do resolve conflict and update its own blockchain. Now, for example, if this 5000 blockchain has a new block, we need to send out a consensus request to the other nodes. We'll write this section from now. For this, let's access projects and blockchain.go. We're going to go back to this for now. If you recall, we had a method with mining. We did mining here, and after we attach the block, we need to hit the API for consensus. So here it's going to be underscore for index, and then range will be BC neighbors. Endpoint will be followed by FMT, sprintf, HTTP, %s. The node is included here, then consensus. We'll hit on this API, then client, HTTP, client, and the rest is the same. Rec is HTTP, new request. We'll simply hit on put, then endpoint, nil. Then next line, resp will be client, do. We'll pass in request, then log printf. So after mining, then our consensus request will be sent. Resolve conflict will be run and blockchain will be verified, and the other nodes' blockchains will be synced. Now that we've gotten this far, let's enter run. There was a method named method, if you recall. And at the very beginning, for example, the blockchain node 5002 is running and there are blocks here. At this time too, the other nodes need to be accessed and do resolve conflict to itself. That's why we'll do BC resolve conflicts. After we run and after we sync, we need to first do resolve conflicts against the other blockchain nodes to rewrite its own blockchain. That's why we entered run here. Now that we've gotten this far, let's see how it works. Let's start our blockchain server. We have our 5000, 5001, and 5002. Then if you don't have your wallet server up and running, please do so. I brought up my browser here, and the most left tab is for our 5000 blockchain. We only have one in here. We'll look at 5001, also has one. The same goes for our 5002. Regarding our transactions, 5000 is empty, 5001 is empty, and 5002 is also empty. We have wallet A and wallet B, and person A is going to send cryptocurrency to person B. We'll copy person B's blockchain address and paste it in person A's wallet's send money address. I just clicked on send, and first let's look at our transactions for our 5000. We have a transaction, and the same for our 5001. 5002 also contains a transaction. We haven't performed mining yet, so our 5000 is showing nothing. The same goes for our 5001 and also for our 5002. Now let's perform mining. After mining, our 5000 transaction is empty. Same with 5001 and 5002. When we go to our 5000 blockchain and refresh, the transactions that was sent is contained here. The reward is also contained. Whether this blockchain is the correct one or not, that's what we want to look at. If this is verified in our 5001 blockchain, then it should be contained here. We'll refresh our 5001 and we can confirm that it is contained. Same with our 5002, we'll refresh and we see the same data. Consensus has been reached and each node has been verified and has obtained the blockchain. That's what has happened, and we're pretty much done with our blockchain. Just as a review of our work and to refresh our memory, we'll be rewriting some parts and running our code later on. And in our next lecture, I'll briefly talk about hacking and then do a demo of our final project.